students, welcome back to askIITians, or should I say, welcome back to the class. So, in the last session, we have discussed about the physical changes and the chemical changes. Exactly. And in that session, I have already told you that we are left with some part of the chapter which we are going to discuss in the next session. So, we are here to discuss the other part of this chapter. Okay, students? So, first of all, I would like to ask you, how are you all? Otherwise, you'll say that ma'am has just came and she just start teaching us. She doesn't care about us, that whether how we are feeling. So, exactly, I hope my all students are good. So, students, what happened is, like in the last session, we have discussed about the physical and chemical changes, if you remember. And at that session, we have discussed that the physical changes and the chemical changes, and even though that what are the differences between these two. So, we have seen that thing that the physical changes are those type of the changes which generally occurs when there is a change in the physical properties, but the chemical properties remain same, and the chemical changes are those type of changes which occurs when there is a change in the chemical composition. Exactly, if you remember that we have discussed some of the example as well, like in the physical changes we have discussed the example of conversion of water to vapor, vapor to water, and we have seen that how the dissolving of sugar is a physical change. Then for the chemical changes we have seen that burning of paper, burning of wood, that how they are chemical changes. Exactly, even though we have seen some of the properties as well. So till now we have discussed all of the things regarding this chapter. Now we are going to discuss the other part, that is the chemical reaction, rusting of irons, uh, rusting of iron, not irons, ways to prevent rusting, and crystallization. So these four topics we are going to discuss in this session. Fine. Now student, what happened, you will say like ma'am, chemical reactions, that chemical reaction is what? It's just that something is reacting getting the product. But student, today we are going to find out the particular way, or we can say a different way to understand the chemical reaction, that what exactly the chemical reaction is. Okay, and then we'll see some of the characteristics of that. Then we'll come to the point that how the iron got rust, or the rusting of the iron. Then what preventions we can take, or what steps can be taken to prevent the rusting of the iron. And then in the last we'll see one of the topic, that is the crystallization process. See, if I told you about what's the crystallization is, so what you can think about the crystallization, that there is a formation of crystals. Now how they are forming, so we'll see that. Okay, so that's how we are going in this flow to complete this chapter in this session only. Fine. So now let's start with this session. So first of all, the very first topic of this chapter, oh, sorry, of this session, actually not the chapter, because we have already started the chapter in the last session. So it's the chemical reaction, student. Okay. So chemical reactions. Now, what do you understand by that? What is the chemical reaction? See, you can say chemical reaction is a kind of the process in which you can say one or more substance react with together, and there will be, like, you will say that the arrangement of the atoms will be different, due to which we are getting different kind of product. Okay, so that's how you can see here that if I show you, see, the reactants are converted to one or more different substances that are called as the products. A chemical reaction rearranges the constituent atoms of the reactants to create different substances as a product. See, student, what happened in the reaction is that if this is a, okay, and this is a B, if they both are reacting with each other, if we have put these the two things in the reaction, so what will happen, that the orientation or the constituent of the atoms is going to be changed, and that's how after the reaction we get the different kind of the substance which we called as the product. Exactly, like student, if I give you one example here, that whenever any process is going on in the industries, like if for example in cosmetic industries, what we are doing, we are forming the cosmetics. So what we'll do, we take some part, like we take some reactant, or we take some kind of the chemical substances, so that they react with each other and they will give the product. Exactly, so that's how student, that always the reaction is like that, that reactants are there, they will react with together, and then we get the product. And what is happening in that reactant, that the some arrangement of the atom will get changed, due to which we get the product. Fine. For example, student, like if I give you an example, like the conversion of milk to the curd. So what will happen that the milk is there. So what happened that whenever any reaction goes on inside the milk, and it will convert into the curd, because what will happen that the particles, or we can say some of the substance or chemical which is present in the milk, the arrangement has been changed, due to which there is the formation of another substance which we called as the product. So that's a student reaction goes on, and for the reaction student we require the reactant. As you can see here that A is a reactant. Okay, see, this is a reaction process to write down that in the LHS side, see, one is LHS converting to the RHS. See, this is the arrow which indicates that this arrow indicates that the reactants are reacting and converting into the product. LHS stands for the left hand side. Okay, and student, remember this thing that at the left hand side we always write down the reactant part, that the species which are reacting with each other, okay, in the reaction, and RHS is the right hand side. Okay, right hand side, and it results always in the product. So that's the reaction student, that the LHS or the RHS, that means reactant are always written at the left hand side of the arrow, and then and the right hand side of the arrow our product is written. So that's how student you will see here that A and B, both them are the reactant, and they both will combine together and form the product. So this is the product student. Now you'll see that A and B, these two are the two different things, but there is a formation of bond. This line which you are looking here, so this line is representing the formation of bond, formation of bond between A and B. Okay, so that's the product students. So that's the reaction, that one, that two compounds are there, two things are there, and when these two things are reacting with each other, so the rearrangement is going on. And how the rearrangement is going on, that there is a formation of the bond between the A and B, and we are getting the product. Fine. Now if we talk about the second type of reaction, now in this second type of reaction, what you are observing, that the bond between the A and B is going to be breakdown. You can see here that A is separated, like A and B both are separated after the reaction. So now for this is the reactant part, and this is the product part, obviously. And see, when there is the, like you can see, when A and B are together, but after the reaction these two both are separated from each other. So what we have observed here, that there is the breakdown of the bond, breakdown of bond. Fine students. So in the chemical reaction student, what exactly is going on? Either the formation of bond is taking place, or either the breakdown of the bond is taking place. It could be anything, like to the any of the side, but it's just that at the left hand side there are the reactant which react together, and then they like either they combine with each other, or either they just split up with each other, or just exchange. So we get the reactant and product. Okay. Now if you see in the third type of reaction, that this is the AB and this is C. Now in this what will happen, this C is going to be formed with the bond with the A, as you can see here, and there is a separation of the B from the A which we are getting. So again now what you are seeing, that the C is replacing the B. Exactly. So see student, it's not always like that only two reactants will be there or only one reactant. It could be number of reactants or number of products we can get, but it's just that in the chemical reaction there is the rearrangement of the atoms, like whether they are rearranging. Fine. So for example, if you see in the first reaction, the two atoms A and B combining together, they are forming the bond between them. In the second reaction, if you see, A and B are formed together, like they are together, but after reaction they are splitting up. That means breakdown is going on. In the C reaction, what you will observe, that A and B is one and C is another one, but C is replacing the B. That means formation and the breakdown both is taking place in one side only. So that's how student you will see now C has rearranged the, like C has undergoes the rearrangement, that it has removed the B from there and it has occupied the space of B. So that's how the formation has been taken place, and that's how we are getting the product as AC as one compound and B as the another one. So that's how you can see the reaction is going on. Now if you see the fourth part, this is the fourth, not exactly fourth part, but the fourth type. A and B are together, C and D are together. But in the react product side, if you'll observe that D has formed the bond with A and B has formed the bond between C. So that is also possible, student. That means what has happened exactly, that the rearrangement has taken place, and that's how breakdown also taken place, and the formation has been also done. So that's how the reaction has been proceed, and we are getting the product. So what exactly the chemical reaction, student? That whether the number of the reactants are there. So when the reactants react with each other, so they will give the product, and we represent this reaction with the help of the arrow, and that arrow indicates that the reactants are reacting and converting into the product. Okay, and that arrow is always in the forward, like the if you see that the arrow part, this arrow part is always in the forward direction. Okay, and it says that the reactants, in the reactant side, there is an arrangement of the atom so that they just get rearranged and we get the product. Fine. So these are the chemical reaction, students. Now, if we talk about that, what would be the characteristics of the chemical reaction? So you can see here that these are the characteristics of the chemical reaction. That first is the evolution of a gas, formation of a precipitate, change in the temperature. Even though, student, if I tell you that obviously we are looking some of the examples here, but the precipitate, that this precipitate is called as the something which is insoluble. Okay, which is not going to be soluble in particular solution or the solvent or the water or any of the liquid, so we call it as the insoluble part, that is the precipitate. So we'll see that how they are going on. So these are the some of the characteristics of the chemical reaction, and for that, student, I am having one video for you, and I would like to show you that video. If you are ready, so just look at that video. Okay.
Most of the chemical reactions are accompanied by the evolution of a gas. When vinegar is poured on baking soda, bubbles of carbon dioxide by the evolution of a gas. Most of the chemical reactions are accompanied by the evolution of a gas. When vinegar is poured on baking soda, bubbles of carbon dioxide gas is formed. Water and sodium acetate are also formed. When sodium metal is added to water, then it reacts vigorously, liberating hydrogen gas and forming sodium hydroxide. When zinc metal is treated with dilute sulfuric acid, hydrogen gas is evolved. The hydrogen gas burns with a pop sound. Certain
So, see, student, like we are talking about that, what could be the characteristics of the chemical reaction? So, we have seen that first of all, the first characteristic of chemical reaction is the evolution of gas. That when two reactants are reacting together, and when the product is formed, so in the product side there is the evolution of the gas. As they have shown you some of the example, like when sodium, what they have taken the example. So they have taken that, we can see here again.
By the evolution of a gas. When vinegar is poured on baking soda.
Okay, yeah, now I got it, because at that point I just forgot what the exact reaction is. So, students, whenever, see, I'll just write down here that thing so that it will be a helpful for you. See, whenever there is a vinegar, so what happened with the vinegar, student? I'll just tell you. Just give me a minute. Okay, so this is a vinegar. Okay, so vinegar contains acetic acid. Okay, if you remember this thing from your acid basis chapter, and when this acetic acid reacts with baking soda, so what's the baking soda is? Baking soda is the base part, which is the you can say that it is the NaHCO3, that is a base. So what will happen, student, when acid, that is the CH3COH, that is the acetic acid, and the NaHCO3 reacts with together, so there is the formation of the sodium acetate. This is the sodium acetate along with the carbon dioxide plus water. And this carbon dioxide, student, if you see this carbon dioxide, okay, I'll just take some dark color. So this carbon dioxide will evolve out. Okay, and this CO2 is having the brisk effervescence. This is a characteristic of the carbon dioxide gas, that whenever there is the evolution of the carbon dioxide, so there is the brisk effervescence. That means you will see that the bubbles are formed there, and there is a some kind of very what I can say, that you will get some kind of order as well, and some kind of you will say that energy is very high at that point. So that's a student, whenever the reaction is going on, so in some of the reaction there is the evolution of the gases, which is very which is very much applicable, or you will be like it is very much visible as well, that okay, carbon dioxide has been formed, so there is some brisk effervescence. And whenever there is a brisk effervescence, so definitely there is the evolution of the carbon dioxide. So as we can see that the acid is the acetic acid and vinegar. So when vinegar reacts with baking soda, so there is the formation of the carbon dioxide gas. Okay. Now if we see the another thing,
bubbles of carbon dioxide gas is formed. Water and sodium acetate are also formed. When sodium metal is added to water, then it reacts vigorously, liberating hydrogen gas and forming sodium hydroxide.
see students, like the sodium is a very reactive metal. Sodium, if I say that it is one of the most reactive metals, so when sodium is added to water, so there is the evolution of the hydrogen gas. So whenever there is the evolution of the hydrogen gas, students, hydrogen gas when has been evolved out, and see, whenever there is the evolution of the gas, so whenever we write down the reaction, so it is represented by this arrow. That means that gas has been evolved out into the atmosphere. That is why we use this arrow that is pointing towards the upward direction. Okay. And always, like, carbon dioxide is having the characteristic that it is having the brisk effervescence. So similarly, the hydrogen is also having some characteristic, and that characteristic is that it revolve out with the pop-up sound. Like if you if you take the candle near to the that hydrogen gas, or to the vapors of the hydrogen gas, so there will be some pop-up sound, and from that we'll come to know that there is the release of the hydrogen gas. So first characteristic of the chemical reaction, is that there is the evolution of the gas, which we have seen from some of the experiment as well, like when the reaction is going on between the vinegar and the baking soda, or we are adding the sodium into the water, so we have seen there is the evolution of the gas.
When zinc metal is treated with dilute sulfuric acid, hydrogen gas is evolved. The hydrogen gas burns with a pop sound. Certain chemical reactions are accompanied with change in color of the products. When green-colored crystals of copper carbonate are heated strongly, it forms a black compound of copper oxide, giving off carbon dioxide gas. When
See students, what happened that first we have seen that there is the evolution of the gas. Now secondly, there is the change in color. Now change in color, how? That you have seen that the there is the copper crystals, and when you see that whenever there is the evolution has been, like when you heat that, so carbon dioxide will get removed and copper oxide is left, and copper oxide is black in color. And in this figure you can also see that these are the copper sulfate, copper hydrated copper sulfate, which is blue in color. But when you heat it strongly, so what will happen, that the water which is present in the copper hydrated copper sulfate, those water molecules will get evaporate out, because water is having the property to get evaporate very easily. So when you evaporate out, so it's just that copper sulfate is left, which is of the white color. So when the copper sulfate is having blue color, that means there is the water molecules are present. And when we have seen that the copper sulfate is of white color, that means the water molecules has been removed. So when it is having the blue color, so we call it as the hydrated copper sulfate, and when the water molecules has been removed, then we call it as the dehydrated copper sulfate, because water molecules has been removed. Okay. So now first, evolution of gas. Second, change in color.
When hydrated crystals of copper sulfate, which are blue in color, are heated slowly, then the crystals lose 5 water molecules, and the color changes to white. Many reactions give off energy in the form of heat and light. Chemical reactions.
See, heat and light. Like if you remember, we have talked about combustion reaction in your chapters. And even though if you know about combustion reaction, in combustion reaction, students, what generally happen that there is the evolution of the heat and light. Okay, so for example, if we talk about the wood, that the wood is undergoing the combustion in the presence of oxygen and we are burning it. So there is the production of the carbon dioxide. That means evolution of gas is also taking place, and even though there is the production of heat as well as the light. So that's our student, that is the third characteristics of a reaction, that there is the that the reaction has been done with the production of the heat and light.
That give off energy are called exothermic reactions. When quicklime or calcium oxide is placed in a beaker containing some water, the latter becomes very hot and starts boiling. It is because of an exothermic reaction.
See student, now what they are talking about the exothermic reaction. So we are having two type of reaction, exothermic reaction and endothermic reaction. So the reaction in which heat is released, that you have seen that when there is the formation of the calcium hydroxide, so along with that the container becomes very hot and it starts boiling, and you will see that the vapors are evolving out. That means there is the release of the energy, and such type of reaction are called as the exothermic reaction. And as well as some of the reactions are there which are endothermic, that means in which the absorption of energy take place.
When a magnesium ribbon is heated from its tip in a flame of Bunsen burner, it catches fire and burns with a dazzling white flame. Some chemical changes absorb energy. Chemical reactions that absorb energy are called endothermic reactions. Sodium bicarbonate absorbs heat to form sodium carbonate, water, and carbon dioxide. Molecules present in the solid are in the state of slow vibrations. When heat is added, the molecules start vibrating vigorously. As the energy absorbed increases, the vibrations also increases, resulting in the breaking of some of their bonds. When the bonds break, the change of state takes place and solid melts to a liquid.
See student, see first of all what we have seen, that there is the evolution of gas. Fine. Then secondly, there is the change in color. Third, that there is the that some of the reactions are done when there is the absorption of the heat or the release of the heat. Okay, and when the heat is like releasing or the absorbing, so there is the change in the temperature. When the heat is releasing, so what will happen, that it is coming very hot. That means temperature has been raised. So that's how there is the change in temperature. Now the fourth thing what they are telling about is that the change of the state. See, whenever there is water and when you boil it, so what will happen, that the particles of the water will start vibrating, and when they are in the very high vibration mode, so what will happen, that they convert into the any other state of matter, that is the gas only. Eventually you have seen that the water is converting into the vapors. So that's a student on heating or on cooling, there is the change in the state of the matter, and like from solid to liquid or liquid to gas, and that's how this is also characteristics of the chemical reaction. Okay. So that's a student. We have seen some of the things, and now, okay, yeah, we left with the precipitate part. So I'll just tell you that precipitate part also. Don't worry about it. So, student, what we have seen till now, that there is the evolution. Okay, just give me a minute. Yeah, so in the characteristics, what we have seen, student, that there is the evolution of gas, exactly, which we have already seen. That whenever, if we talk about evolution of gas, for example, when the vinegar or the acetic acid reacts with the what we can say, that is the sodium hydrogen carbonate, or we can say the baking soda, so there is the release of the carbon dioxide. So some of the reaction evolved out the gas. Now secondly, what we have seen change in color. Okay, so there is change in color, students, as we have seen this thing, that whenever the copper sulfate is present with the 5 molecules of H2O, this is the hydrated form. That means at that point, more water, that the water molecules are present here and it is of the blue color. But when we start heating it, and after some time, what will happen? All of the water molecules will get evaporated out and we just left with the copper sulfate, that is the dehydrated one, and it is of the white color. Okay, so that's how we have seen the change in color as well. Now if we talk about change in temperature, so students, if I write down here again, that in the change in temperature, student, there is the two conditions. Now what are those two conditions? That, see, first is the exothermic reaction is there, and third there is the endothermic reaction. So what will happen in the exothermic reaction? There will be the absorption. Oh, sorry, there will be the release of energy. I'll just release of heat. That means heat will get released in this reaction, and in this condition there is the absorption of heat. And obviously, student, heat is what, like whenever there is the more heat, so the temperature will increase, and whenever there is the less heat, so the temperature will decrease. So that's how, student, temperature is changing whenever we observe whether the reaction is absorbing the heat or releasing the heat. As well, we have seen the examples also. Exactly. So that's the change in temperature. Now, then what we have seen, change in state. So in the change in state, students, what we have seen, that it's just that, for example, student, when there is the ice cube, okay, and when you take out that ice cube and you start like when you start boiling it, or even though you don't require to boil it, it's just that when you take out that ice from the freezer and you put that in the outer surrounding, so what will happen? In the freezer, the temperature is less. Exactly, temperature is less. But when you take out in the outer surrounding, so in the outer surrounding, temperature is more. So what will happen? That ice will melt, that it will undergo the melting process and it will convert into the water. So that's a, student, it is also kind of the characteristic of the chemical reaction, that there is a change in the state because reaction is taking place only. So that's the, you can say this is also characteristic of the chemical reaction. Now if we talk about the formation of precipitate, that whenever there is a formation of insoluble thing, for example, student, that whenever we are having some kind of solution, and if we are adding something which is not going to be soluble in that, and it will form the precipitate. For example, I'll give you a very simple example, that is the chalk solution. Okay, even though we are having some another example as well, but if I give you the example of chalk solution, so if you're having the water and if you add the chalk into it, so chalk is like, some part of the chalk will get soluble into it, like some part, because of that the color of the water will get changed, that is the white. But you will see that some of the particle or some of the part of the chalk is settling down at the bottom of the that beaker or that glass. Why? Because it is the insoluble part, or it is converting into the precipitate. That is why it is settling down at the bottom, and that is the formation of the precipitate only. And this is also characteristic of the chemical reaction. Even the student, there are some other type of the precipitate as well formed from the different type of reaction. Okay, and they are also having different color. So these are the characteristics of the chemical reaction. First, evolution of the gas. Second, change in color. Third, change in state will be there. Fourth, change in temperature. And fifth, that's the formation of the precipitate. Exactly, and we have seen the example of each one of them. So these are the characteristics of the chemical reaction. Fine. Now we are going to study about the rusting of iron. As I have told you, rusting of iron as well. So in this picture, what you can see, student, that this is the iron. Okay, this is the fine iron, but you can see that this is the damaged one, damaged iron. Okay, and you can see that this damaged iron is having some brown color layer over it. So this due to the deposition of this brown color layer is called as the rusting. Now how it is going on? See, when substances made up of iron are exposed to oxygen and moisture in the atmosphere, there is a formation of the brown red color layer, which we called as the rust, and that's the whole process is called as the rusting of iron. As I have already given you one example, like most of the students are having their own bicycles, exactly. And what happened? And if its body is made up of the iron, and that bicycle is standing outside in the open atmosphere, so due to the in the contact with the oxygen and the moisture, what will happen after some time? It's not a very fast process, it is a very slow process. Okay, just remember one thing, it is a slow process. It's not like that within 1 or 2 days you will be find out the rusting. No, it's a very slow process. So what happened that iron in the presence of the oxygen, it will form the iron oxide. So this is the formula of the iron oxide, student. Okay, so this due to the formation of this iron oxide, that is the red brown color layer, which we called as the rust. Okay, and you can see that the chemical formula for the rust is Fe2O3NH2O. This N depends upon the that what amount of the moisture is there. Okay, moisture is what? Water particles only. So there more will be the moisture, quicker will be the formation of the rust. So that's how, student, this N represent the number of water molecules. Fine. So this is the rusting of iron. Even though what you can do is like you can buy a very new or very clean iron nail, and you can put that iron nail outside somewhere, and it's just that after 15 days or 20 days, or even though after 1 month or 2 months, when you will see that iron nail, or if you start observing it to the very first day, you will not find out anything. But after 1 month, when you see that iron nail, what you will find out that there is the formation of the red brown color layer, and that is called as the rust. Because, student, when iron is in the is exposed to the oxygen, to the open surrounding, because in the open surrounding is what? Oxygen is there, exactly, and the moisture is also there. And when iron comes in the contact with the oxygen and the water molecules, that is the moisture, that is the particles of the water, so there is the formation of the red brown color layer, which we called as the rust. And this whole process is called as the rusting of iron. Okay, see, student, rusting of iron is also a part of the corrosion. In corrosion, what happened that the metal is eaten up by, like, we can see that with any process. So that's in this process what is going on, that oxygen and moisture will eaten up the iron, and what will happen, there is the formation of the iron oxide, and that iron oxide with the water molecule, they combine and they form a chemical formula of the rust, and it depends upon the amount of the moisture in the air. More is the amount, quicker will be the formation of the rust. So this is the rusting of iron, and as I've told you, it is not a very fast process, it is a very slow process, which you can also observe. If you want to do it, you can do it very easily, and there is nothing harmful in that. So if you want, you can put one iron nail outside somewhere, and you just start observing it very first day, you will not see any change, even though after 5 days there will be no, 10 days, no, but yes, after 10 days there will be starting of the rusting, and after 1 month, what you will see, that there is a very dark layer of the brown of the rust, and that is the rusting of iron. Okay, but see, student, rusting of, once the iron is like, when what happened, like once there is a formation of the layer over the iron of the rust, so the reversing of that is very difficult, it is not possible. That is why we call this rusting of iron as the chemical change. Like we take the example of rusting of iron as the chemical change. Okay, because it is not reversible in nature. But see, we can prevent this rusting of iron by following some of the ways. Okay, so we are going to study those ways only. So these are the ways, by using them we can prevent the rusting of iron. So first of all, it is the apply oil. See what happened when there is the iron, and it is iron, and this is oxygen and moisture, and when the iron is coming in contact with the oxygen and moisture, then it is getting rust now. So what we have to do is that we have to cut the supply between these two. When the supply is not there of the oxygen or the moisture, so how it will get rust? Exactly. So we have to cut that supply. So to cut that supply of the oxygen, or to cut the contact of the oxygen or the moisture with the iron, we are having some of the ways which we can do and we can prevent the rusting. So first of all, it is the apply oil. See, if this is the iron sheet and over that iron sheet you are applying the layer of oil, so what happened, where the oxygen or the moisture which is present in the atmosphere, there is not direct contact between the iron and oxygen, so there will be no rusting. Exactly. Applying a dry coating, obviously student, when there is the iron and you are applying the dry coating of anything, so again there will be no contact. When there will be no contact, so again there will be the prevention of the rusting. Paint the metal, it is very useful students, even though, like when there is the iron and if you paint it with any of the color, so that paint will act as a insulator. Insulator means that it will not allow the oxygen or the moisture, that is the water particle, to come in contact with the iron, and that's how you can prevent the rusting of the iron. Okay. Store properly. Like store properly how, like if your bicycle is somewhere standing in the outside area, so what you can do is you can make a place inside your house so that you can take your house inside, so that there will be no rusting. Exactly, that you have to protect your iron substances so that they will not come in the contact with the oxygen or the moisture. So that's the another thing which you can do. Now the fifth process is galvanize. See, this is also called as the galvanization process. And in this galvanization process, what happens, student, that we deposit the layer of zinc metal over the iron substance, that we called as the galvanization. So due to that, student, what will happen, that zinc will what it will do, that it will protect the iron from the rusting. How? See student, whenever there is the iron and when it comes in the contact with the oxygen, okay, so it converts into the iron oxide. Okay, and this formation is called as the oxidation process. Just try to understand my point. This is the oxidation process. See, what's the oxidation process, student? Whenever there is the addition of oxygen is taking place with any of the substance, we called it as the oxidation process. That means you can say, student, that the rusting of iron is a kind of the oxidation of the iron. To prevent that oxidation of the iron, what we can do, student, we can use the zinc. Because what will happen, that zinc will oxidize and it will not allow the oxygen to come in the contact with the iron. So that's a, student, we can use any metal which will not allow the oxidation of the iron, and that is the zinc. So that we use the zinc layer over the iron substances, and that's how it will protect the iron from the rusting. And this process is called as the galvanization process. Okay. Now the another process is the bluing. See, in this part, what we'll do, that we are having the magnetite. Okay. Magnetite is Fe3O4. This is the magnetite, student. When you cover up your iron substances with this magnetite, so again, student, the iron is not in contact with the oxygen and air, and there will be the prevention. Powder coating. So again, student, see, all of these are things similar in nature. It's just that we are using different source. Like in applying oil, we are using oil, dry coating, metal, painting of the metal, storing properly, zinc we are using, magnetite. We see all of these things. What they all are doing is they are just making the what they are just making is that they are removing the contact between the iron and the oxygen. They just don't want that oxygen or the moisture will come in contact with the iron. When they will come in contact with the iron, so what will happen, obviously iron will get rust. But if it is iron and if it is this oxygen and moisture, and if we put some barrier in between them, so obviously there will be no contact in between them, and when there is no contact, so there will be no rusting of iron. So that's how these are the ways which you can use to prevent the rusting of iron. Okay. I hope you all understand the rusting of iron and how we can prevent it. So among all of these, if you find out which is one of the great option, it just that store properly, that don't allow your bicycle to stand in some open area. Exactly. But it's just that all of them are very good. Like all the things or all the processes or all the ways are very nice to do, but like store properly is that we don't have to anything, we just have to make them like to be stored properly so that there will be no oxygen or the moisture. Fine. So these are the ways to prevent the rusting of iron. Now, the last part of this chapter is crystallization. So, student, crystallization is a technique, you can say, for the separation as well, so that you will separate out. In this case, what we'll do exactly, separate the pure substance from the impure one. Okay, generally this technique is used at that purpose so that the impurities will get removed out and we just left with the crystals which are pure in nature. Okay, so it's that the process of separation of salts from their solution is called as the crystallization. Okay, it is a purification technique. Exactly, when we are removing the impurities from any of the solutions so that we get the pure substance from that. So obviously it is the purification technique that purifies the seawater or separate the crystals from the impure sample. Okay, so that's how student there is the, and it is a physical change. For example, student, like I'll just show you again that these are the crystals. Okay, that example is that the seawater we don't use for a domestic purpose, exactly, because it is salty in nature. Salty in nature. So what we'll do, like what, not exactly we, like the people who just do this work, so they make a large pit and they pour the seawater in these pits, and what will happen whenever there is a sun. Okay, so don't go by my drawing. So these sun rays will absorb. So what they will do, they will provide the heat, and the water which is present over there, that water will get evaporate out into the form of the vapors. And there is the formation of the crystals. There is the formation of the crystal of salt, and that salt, student, we use in our houses as well. That is why, student, whenever there is a formation of the crystals from the impure solution, so we call it as the crystallization process, and it is a purification process. And see, student, this technique is most of the time used in our laboratories whenever we have to find out some pure crystals of the we can say whenever we are making dyes or we are making any compound and we want the pure crystal. So what we'll do, we take the impure solution and we just cool it. So there so even the cooling will be done, or even any other thing. So in the cooling, what we'll do now, that there's the formation of crystals, and the other part of the liquid we can decantate it. So that's how it can take, and even though with the help of the heating we can also do this thing. So that's how there is the separation of the crystals and the impurities will left behind, or you can say that the impurities will get evaporate into the atmosphere, and that's how we get the crystal. So this is the purification technique, student, which we use so that there is the formation of the pure substance from the impure one. Okay, so this is the technique which is in your syllabus, and with that we have completed this chapter. Nice, na? Okay, so we are having one question here. So what's the question is, when baking soda is mixed with lemon juice, okay, lemon juice, bubbles are formed with the evolution of gas. What type of change is it? Explain. So when baking soda is basic in nature with lemon juice. So lemon juice is what? It is acidic in nature, exactly, as it is sour in taste, if you remember, and baking soda is basic. Bubbles are formed with the evolution of the carbon dioxide. So there is the formation of the carbon dioxide because the baking soda is what? It is NaHCO3. So baking soda is NaHCO3, and lemon juice is having the citric acid, whose formula is somewhat difficult. So I don't remember, it's somewhat big. So don't worry. So whenever there is the NaHCO3, so there is the evolution of the carbon dioxide, and as I have told you, there is the formation of bubbles as well as there is the brisk effervescence of that. So that's how, student, there is a formation of the carbon dioxide and other substance will get formed. And they have also asked you that what type of change it is. So obviously when these two are undergoing the reaction and there is the formation of the new substance, exactly new substances getting formed, and this reaction can't be reversed. So this type of changes, what we call them as chemical changes. So that is why when baking soda mixed with lemon juice, so there is a evolution of the carbon dioxide gas and new substances formed, and that is why this is the chemical change. Okay, so we have completed this chapter, students. Now what your work is, watch this video very carefully, learn each and everything, and try to make your concepts very clear about chemical changes and rusting of iron and chemical reactions, everything, because chemical reaction and their characteristics you are going to find out in your class 10th also. So just clear your concepts. And even though if after listening this video you are having any question or any query comes to your mind, what you can do is you can put your questions over the public or private forum of the Ask IITians, and you will get your answers from expert side, and that's how your chapter will be done for you. Okay, so thank you for attending this session, student, and keep learning from Ask IITians. Thank you.